Hi, this is Margo. This is Sunday afternoon, December the 22nd, 2019, and I'm going to do a methane update. We're going to look at CAMS data and the NOAA data for methane from yesterday, the 21st, and I also have a sea ice update for you. So, I'm not feeling well. It's been a really hard week, but I did get everything merged down into one storage unit now, and that kind of took it out of me. And anyway, I still have a lot of work to do, but I hope everyone is doing well as possible. And I've got a little bit of a special show today. We're going to be comparing sea ice thickness from the Navy model back to 2014 for this time, for December 22nd. We're halfway through the dark season up in the Arctic. It is dark up there right now, and everything is supposed to be refreezing and thickening up and everything. So we're halfway through it, and then in April, when the sun starts coming up, then it'll start melting again. So that's a little bit special presentation I've got for you today. So we're looking at Copernicus Atmosphere Monitoring Services here, and we've got methane. And they just put up the data from yesterday, Saturday the 21st. I have the Arctic view and surface level pulled up. And I'd like to thank everyone who left such wonderful comments under my video from last week talking about, the paper I presented about why there are higher methane releases in the Arctic in the wintertime. And that was really eye-opening for me, and we do see that happening here, specifically in the area where the paper was talking about the Barents Sea over here to the west of Novaya Zemlya, and the Kara Sea to the east of Novaya Zemlya. We're seeing high releases and moving out, and so we had a lot of good comments, and I'm going to share one of them today. But I had a lot of really good comments, and I'd like to thank everybody for chiming in and being part of this community. And as we understand and see what's going on, we can better prepare for what's happening and the eventuality of everything, and realize that the end is coming for all of us, and it's coming quick. And I'm also going to share a Sam Carana post that he posted a couple of days after my show. So the data is from Saturday, and then the forecast period runs Sunday through Wednesday. And we can see in the forecast period it's even coming up through the sea ice as it's moving across, that wave moving across. So here it is back in with the data. Huge releases in the Kara Sea and off of Novaya Zemlya. And then these waves just keep moving out, and we also have high releases over here in the Chukchi Sea near Bennett Island is right here, and we've even got red coming up around Svalbard. We've had some Arctic earthquakes this week. We've had a series of earthquakes down here just south of Iceland, right on the Reykjanes Ridge. right on the red line. And so there's a lot of movement happening, and as the earthquakes happen, it's also releasing methane and sulfur dioxide and all kinds of other stuff too. So that's the Arctic view. So we can see high releases, and we understand why they're so high right here. It was because of the layer of seawater that acted as a stabilizing force that was there in the summertime isn't there in the wintertime, the picnicline. And so it allows the methane to go ahead and bubble up. So let's look at the North Pole view. We can see the northern hemisphere here. Let's run this. North America, it looks awful, and from Midwest all the way over, it's just covered up. We're also seeing very high releases here in Southern California and out in the ocean. And look at this burst coming across the Atlantic Ocean. Watch here off of this eastern seaboard. Watch here. There's going to be a red arm. Watch this red arm come out. This is surface level. And then here's another burst that comes out, and look how it's just traveling across the Atlantic. That's so freaky. It's just hard to wrap my mind around these huge releases. Although when we look at the NOAA data for the 477 millibar or slash 469 reading, we're going to see a decrease this week. But but we're seeing high releases at surface level. Let's look at North America now. And here's Canada. This is an area that has constant releases. They have tar pits up there and lots of oil stuff going on. Now look down here. Look, all through the midpoint, the Valley of California comes straight down. Here's the San Francisco Bay area, and it's all around there. It's black right there. And here's the Southern California area, LA and San Diego. But look at this huge area where it's coming up out of the ocean. That's just kind of flipping me out. So let's run this. I haven't loaded this movie. We're also still having a lot of earthquakes in the Ridgecrest, Searles Valley region. Those have not stopped. They've gone down and then they go up, and it's a constant thing now. Look at this wave that just moves across, releasing all the way across the United States here. And here's that burst that moves out, that came out from Canada. So we know that there are underwater volcanoes out here in the ocean, and we know that there's methane coming up all the way along the coastlines, pretty much everywhere, but especially out here in California. We also have the San Andreas fault line running up here. Then we have this Cascadia zone up here. So it's not looking good. Okay, let's look at, I want to show you Australia too. They've got high releases on the east coast. This is because of the fires burning. Sydney has had awful problems. They've had some deaths. They've had lots of structures starting to burn. But we can see all the way down this east side. Over here on the west side too, we're seeing lots of methane. But this is from the fires that are burning. Also, New Zealand has high releases, especially on this North Island. Now it is their summertime down there, and they've had off the chart record temperatures down in Australia, and no rain. And I watched a video this morning that Robin had posted in his blog post about about what's going on down there, and it was from Max Egan, and he was talking about all the fracking for the oil wells going on, and they're using the water to run the fracking from the dams. They're using water that's dammed up but not releasing the water to go to the people. It's a whole thing. It's very criminal what's happening. So it's not just climate change, it's a combo plate. It's a whole combo plate of stuff. And then, you know, they've got the chemtrailing and all that too, like we all do. And 5G and the beaming, and it's just awful. So here's the global view for surface level. And if we look at 500, let's go over here to 500. That's about halfway up in the atmosphere. This is what we can see. Let's refresh this chart. And we can see that the higher levels tend to gather in the Arctic, more cooler regions, the more northern regions at this level. And then when we look at total column, here's what it looks like, total column. That's where it's added up all the way through the level, the different levels all the way through the atmosphere. And so we can see on total column we've got red popping up in areas that we didn't see before a couple of months ago. We've got red popping up in Southern California, which does not surprise me. Let's just look at a few views at this total column level. This does not surprise me considering what we saw down there. And it's in the orangey region, in this whole area where it was that dark brown over the ocean. We've also got some red up here in Canada, a little bit of red over here. And then the orangey pops up. That's the next color before the red. Let's look at Eurasia. We're seeing reds. This is China over here, I think. This is Russia up here. Yeah, this is. And look at the reds and the dark reds popping up. This is Korea, north and south. Then this is China. This is all China and Asia down here. So it's definitely not looking good. Spreading out, we're seeing red over the Pacific too. Let's look at the Pacific view. Here's the Pacific view where we're seeing some red and the orangey. So it's definitely getting higher total column throughout. That's a weird pattern there. Almost looks like a hieroglyphic letter or something. Anyway, now the next part of the report. So let's leave this as a backdrop. The next part of the report will go to the NOAA methane readings for 469, which says 477 when you click on the thumbnail. It says 477, and then when you get over here it says 469. So this is what we've got from Saturday the 21st. Met-Op-1 satellite in the morning. The range was 1375 to 2366 parts per billion, and the mean or the average was 1873 for the globe. So the fuchsia color, that's from 2000 and higher parts per billion. Okay, Met-Op-1 satellite in the afternoon. It was 1433 to 2371, and the mean was 1878. And the Met-Op-2 in the morning, we have a lot of missing data. Look at these huge white patches, so about half the data is missing. But from this, the mean is 1450 to 2292. The range is 1450 to 2292. The mean is 1853. And in the afternoon, the reading was 1442 to 2379, and the mean was 1856. So when we plug those numbers into our spreadsheet, we come up with an average for this level of 1865 parts per billion, and last week it was 1867.5, so it's showing a decrease of 2.5 parts per billion this week at this level. So here's our graph over here where it's going. Here's where it was holding, and it had stayed the same from the week before. So here's where it had stayed the same, and here's where it went down this week. And it's still, since I started doing this from March 1st, it's gone down, it's gone up 7.75 parts per billion. This is where we started on March 1st, 1857.25. But this is typical. It's typical for it to be going down and then start going back up. Usually around April. It started going up early this year, and so there's that. Now the next part here is pictures from Climate Reanalyzer for sea ice and snow cover. My last show where I showed sea ice and snow cover was from December the 10th. So it's been a while. It's been almost 2 weeks. So we'll be able to see a change in the sea ice and snow cover. So here's what it looked like on the December the 10th. I think I missed a couple of days. Here's the 12th. I missed the 11th. Sometimes I get sidetracked and can't remember if I did them or not. I do it most days though. Here's the 13th, 14th. We're watching this area here in the Bering Strait. Watching this area trying to fill back in. This was an area that it's having trouble filling back in, and it is coming back. There's the 15th, 16th, and the reason was because the air and the water temperature were too warm for it to come back. Here's the 19th. I missed the 18th. Here's the 20th, the 21st, and here's from today, the 22nd. And we can see there's still a little hole right there. The extent over here on the east side was about the same. It's filling in a little bit more here in the Baffin Bay and here in the Hudson Bay, and it's mainly thickening up is what we're seeing. Now, this is the sea ice thickness from the Navy, U.S. Navy model, their computer model. This is from today. The reading was taken on the 21st, and it was projected for today through the 22nd. So you have to look up here for the day. It's not necessarily down here. This number is the day they took the data and did the projection. And oh, this is last year. Sorry. Thought I was okay. Here we are. They took the data on the 19th. That's right. And then it's projected for the 22nd. So if you go to their website and just click on the current one, it's going to show the 20th. But you can go, I'll show you how you can do that, how you can find it. Like if you click on sea ice thickness, it says for the 20th. But they took the data on the 19th. But if you go back and you go to Snapshot Archive, they have the 2019 and 2018 on this page, and here it is, and here's the one here's the run, the day of the run, and here's the projected date. And so here, the last run was done on the 19th, and so here it is projected for the 22nd, and that's how you can find it. And then you can just do a right click and do save image as, and that's how you can get the current date, if you don't know how. But now you know how to do that. So here it is for today. Let's blow this up a little bit. What we're seeing, we still have a lot of purple, which is 1 meter or less thickness of sea ice. And when we get to the darker purple and into the blue, that's the dark blue is about 1.25 meters. When we get into the dark aqua, it's 1.5 meters. When we get into the lighter aqua, we're getting into the 2 meters thick, getting into the thicker ice. And when you get into the green, you're going up to 3 meters, and getting into yellow, it's about 3.5 meters, and orange is 4, red is about 4.5 meters, and so forth. So here's what we're seeing. We're seeing a little bit of red coming in here at the northern part of Greenland, just a little tiny bit. Most of it is still lavender and in the purple range, so 1 meter and under. And here's the dark blue coming in at 1.25, and here's the dark blue-green coming in at 1.5. But we're seeing that the thicker sea ice is just kind of hugging this Canada area, is just kind of staying in one place, and it's not really moving out. So it shows me that the water underneath is warmer and the air is warmer, keeping the sea ice from getting that much thicker. We're getting a little bit of thicker sea ice around the coastlines here, and here. Now, here's Svalbard. It's still pretty much ice-free around the west side, and the south side is Svalbard. Here's Novaya Zemlya. It's ice-free on this west side. It's coming back a little bit on this east side. And then here's that hole that we saw on Climate Reanalyzer. It's trying to come back. Maybe it'll be filled in by our next ice report. If we go forward, here's the 30-day animated GIF, where it goes back 3 weeks and forward 1 week in the projection. So it goes through December 27th on this animated GIF. And so what we're seeing is this thick ice is just kind of hanging out. It's not coming on down to the Beaufort Sea. It's trying. The North Pole is here. Okay, now let's go. So here it is. Now we're going to do our comparison. So here it is from today, the 22nd, 2019. And we're just going to go back to back to 2014 because that's where this model goes back to on the website. Here's what it looked like this time last year, and we can see that the thicker ice was further down and all the way across this Beaufort Sea and along the coastline of Alaska even, and it had closed up. There was ice all the way along here. It wasn't very thin, but was starting to refreeze along there. Svalbard did not have as much ice around it at all. So the ice is different every year. But what we're looking for is that thick ice. Now see how it was refreezing in the tributaries? But this year it's barely coming back in the tributaries. There's not much of that thick ice coming back there so far. So there's the 2018. Here's 2017. So we can see that the thickness was more spread out across the Arctic here. Here's 2016. They had a bad sea ice year in 2016. It was quite low. 2015, and you can see a big difference here with a lot more of the thicker sea ice. See how much further out it went up past the North Pole, and even there was an area here just further up from the North Pole that was thicker. And here's 2014. And here's a huge difference. And look how this thickness, the thicker ice, went almost all the way across this Chukchi Sea to Siberia. And we had it into the greens and the yellows and the reds here in a lot more areas. So that's where we're at, halfway through this dark season up there. So I think it's interesting to go back and see where we came from. And there it is today. And I also made a movie for you. Let me see if I can find it. Oh, it's in this one. Alright. Hang on. Had to find my movie. This is from NASA Worldview, starting on December the 8th. This is the sea ice concentration. It goes through the 20th. And the blue shows where it's less concentrated. And the white is where it's more concentrated. But we can see it day by day. Coming out, going back. Here's that little hole. Started out as a big hole up here, and then it started filling in during this period, and there it is there. So there we are. Now let's move on to our websites. So I showed you how to get the current day on the Navy website. Here's the National Snow and Ice Data Center. Here's their daily for the Arctic sea ice concentration. Here it is from yesterday, and we can see it correlates with what we just saw from NASA Worldview and from the Navy. Here's their graph for the extent. The extent is different than the concentration. Extent means how much is actually, out on the surface. And it had been at the lowest, and then it came up. This dotted line is 2012, and so we're kind of tied with 2012 for this current, where we are right now. This time in 2012, we're kind of tied, so it's about the same. And we can peek at the Antarctic while we're here. Here's sea ice concentration for yesterday. We can see these areas where it's totally melted around the coastlines, and it's totally melted here in the Weddell Sea and around. And on this graph, the blue line is this year, and this dark gray line is last year. And so we're about tied. We were below last year, so it looks like it's about the same. It's a little bit higher than last year. It's about the same. Now let's go to Climate Reanalyzer. This is from today. Here are the temperatures. Let's look at the maximum temperatures from today. And we can see on the globe, Australia stands out from the crowd, and it's very hot. Very, very hot, up above 40 degrees Celsius through over most of the country. Extremely hot, and the wildfires are just still burning out of control. It's been going on for weeks, so it's just not good. Here's the 2-meter temperature anomaly map from today. This is the air temperature where it's warmer than normal. We can see higher area where it's warmer than normal over that area where that sea ice is trying to come back, where that hole is. Then over the Arctic areas where it's warmer than normal. Then here's the United States and Canada. For the world, it's up 0.7 degrees. Northern Hemisphere is up 1.1 Celsius. The Arctic is up 1.8 Celsius. The Antarctic is up 1.7 Celsius. Southern Hemisphere is up 0.3 Celsius. And the tropics are up 0.7 Celsius. So we can see the Antarctic area is, a lot of it's in the brown too. It's kind of easier to see when you click through. Now here's Europe. Now up here is where we saw these high releases of methane coming out of the Kara Sea, and also out of Europe too. And Russia high. It's just strange these pockets of places, it's just, there's really no rhyme or reason. Here's Australia. We can see how most of the country is warmer than normal. Here's New Zealand. There's a hot spot down here in the Pacific Ocean. I don't know what's going on there. I think that there's an underwater volcano there that they haven't really talked about. And then here are areas in the Antarctic that are much warmer than normal. Here's your precipitation. See, we can see that Australia is just totally dry. Totally. There's not a drop of water coming down there. Let's look at the jet stream now. Just totally totally out of control, out of whack. And then here's your sea ice and snow cover that we talked about. We already saw that. And sea surface temperature anomaly. This is from Thursday, so they're behind a few days. Now this is where the sea surface temperature is warmer than it should be, or warmer than normal. Look how hot it is just south of Greenland and all the way up in this Baffin Bay, and the ice is having a hard time coming back here. It's actually up in the red zone, up around 5 degrees warmer than normal. Here's Iceland. All the water around Iceland's warmer than normal, and so on. Here's the Bering Strait, and look at where it's coming in from the Pacific. It's so warm. The Atlantic is warm. Look at the Gulf. It's the oceans are not looking good. And here's that hot spot that we saw in the Pacific Ocean. It's higher than red. It's into the white, or pinky white, which is 6 degrees warmer than normal. So let's just click around so we can see that. There it is at the bottom. It's to the east of New Zealand. I'll bet they're glad they don't have that right over them or around them. And look at the water all the way around Australia. It's in the browns. And then this huge red area over here to the east of New Zealand. I just can't help but think it's something underwater causing that. Maybe volcanoes going off. We haven't seen earthquakes in this area, but it could be underwater volcanoes causing the water to heat up. I don't know. So worldwide, the oceans are 0.3 degrees higher. Northern Hemisphere is up 0.4. The North Atlantic is up 0.4. The North Pacific is up 0.4. The Southern Hemisphere is up 0.2. And the Equatorial Pacific is up 0.2. So there's that. Now let's take a look at NASA Worldview. Here are the fires from today. I'm going to refresh and see how much more data has come in. That's pretty much everything. And it's amazing when we turn on this fire layer how we see these fires just going on all the way across Africa and down here through Asia and India and over here. But look at Australia. This is what I wanted to show you. Here's this smoke. Look at this smoke, how dense it is coming over. And this is a cloud that's kind of mixed in with the smoke. If we go back to yesterday, we can see, look how the smoke just is coming all the way inland. And they have fires up north too. It's not like it's just over here on the east side. The Sydney's down here. And that's what we're hearing about, is structures being threatened. A lot of structures have already burned up, and the last I heard was there were 8 deaths, I think. I could be wrong, but quite a few structures have already burned up, and the firefighters are really having an awful time of it. But see, it's all the way up the coastline. And then up here in the north, they've got a lot of fires. And here on the northwest, they've got fires. And here in the southwest, they've got fires. So they've definitely got problems. So we need to keep all these people in our prayers. Let's go back a couple of days. Look at the smoke here. This is from the 20th. Here's the 21st. We can see it coming down here. I mean the 19th. Here's the 18th. 17th. And so forth. They're just not getting a break. There it is today. It's awful. And another thing I wanted to show you, we'll turn that fire layer off. We're still tracking that huge iceberg that broke off of the Methane Sea Ice shelf. I'm the only one tracking this, I think. It broke off from this area in 2017 and has been moving up, traveling up, and I want to show you its progress here. It's hard to see today, it's cloudy, but if we go back to yesterday, it's right here. It's all the way, moved all the way up to this tip of this western peninsula, this little island, the very furthest out. This is land here. It's a little bit further out north from that. It's on the move. It is on the move. It's a huge iceberg. A68. Here you can see the outline of it. You can make it out through the clouds. Here it is from the 17th. Here it is on the 13th. Now see where it was on the 13th? This northern edge, if you draw a line straight across, it was down here. But it's equivalent to up here now. Just at the 13th. Here's the 10th. This is a pretty good picture of the 9th. So on the 9th, it was down here. The northernmost edge. The point was here. You draw a line straight across. It was about equal to this little tiny island. But let's just go to 21, which was yesterday, and you can see how much it's moved. See, it's up here. It was down here. It's amazing. And then here's today with all the clouds. So I'll keep showing that. And that's fresh water, I think. It broke off of the ice shelf. So it should be, well, I don't know if it's fresh water or ice water, or, salt water. If it's fresh water, they could harness that. They could lasso it and go and melt it down and take it to Australia and put the fires out. Here's Pine Island Glacier. It's still, we can still see parts are coming off here on this edge. It used to go all the way down here, but this is where it's been calving off every year. There's an active volcano underneath there. That's heating everything up. This is the Thwaites Glacier. This whole area is the Thwaites area. So the ice has come away. These are clouds here. The ice has already come away from the, here's a good image, from the coastline, as you can see. Down here is the Ross Sea. This is the Ross Ice Shelf. Right down here, this is Ross Island that kind of comes out with this, kind of comes across. These are volcanoes. This is Mount Erebus. It's an active volcano. It's been giving off sulfur dioxide. I've been looking at that on CAMS. So this is a really good view today. It's totally cloud free. The McMurdo station is somewhere over in here, this area. Then over here is the Amory ice sheet, where it's flowing down. through here. It's kind of cloud covered today. If we go back, here is the piece that broke off from down here, and it's still out here kind of bound up in all of this sea ice. But it broke off right down here. I think it was the end of October. So the sea ice around the Antarctic normally does pretty much melt in their summertime. Remember, it's daylight down there 24/7. Here's the Brunt ice shelf. So they're not getting a break. There is daylight 24/7, and things are melting and heating up. Here it is from today. We can see a cloud going over there. This is the Weddell Sea. This is the Weddell ice shelf here. And this is the Larsen Sea ice shelf. Larsen B was up here. It pretty much broke up and went away. Larsen A was up here. It's already gone away. Now let's hop over. I just want to show you earthquakes real quick. We've got 297 in the last 24 hours. But I wanted to show these Arctic earthquakes that we've had. Let's go to 7 days, all magnitudes. Right up here, well, we've had a ton of earthquakes on these Aleutian Islands for one thing, and there have been a few over here on the Kamchatka Peninsula, and a lot of earthquakes up in Alaska, and of course all around the Ring of Fire. But what I wanted to focus on, here was one up here just south of Svalbard, right on this red line. This was a 4.8 that came in on the 17th. And then down here just south of Iceland, south between Iceland and Greenland, there was a cluster of earthquakes on the red line on the Reykjanes Ridge. There were 6 that came in, all within a 24-hour period, and these started on the evening of the 19th. Started at 21:44. Would have been 9:44 my time. I'm sorry, 11:44. No, 9:40. I'm having a brain fart. 9:44. So there was a 4.6, and then a 5.0, 4.7, 4.6, 4.6, and 4.6. That last one came in at 3:27 on the morning of December 20th. And these are Pacific time. I've got it set to my time zone. So that was an interesting cluster that happened all together there. So we've had a lot of activity. And now I'd like to read this one comment from Sultan Bev that came in under my last video where we were talking about methane. And he says 10,000 parts per billion CH4, that's methane. And the 10,000, remember, is the high reading. Let's go back on CAMS. If we go to surface, let's go back to Arctic view. And then we got to refresh to get the correct chart. So what he's talking about is this dark brown color, which is up here, all the way up here. It's when you see it in this color range, it's between 2160 and 10,000 parts per billion, according to this chart. So that's what he's referring to. He says 10,000 parts per billion CH4 is the same as 10 parts per million CH4. The average shown in the CAM picture is 1950 parts per billion, or 1.95 parts per million. As each CH4 molecule has global warming potential equivalent 86 times that of CO2 over a 5-year period, the CO2 equivalent is 1.95 times 86 and equals 168 parts per million. Add that to the existing 415 parts per million CO2 and we get an equivalent warming of 583 parts per million. That's the average. At those peak columns of 10 parts per million CH4 gives you a massive 860 parts per million CO2 equivalent plus the 415 parts per million CO2 already out there, an incredible 1,285 parts per million CO2 equivalent. That's insane! Once the average gets to that level, studies show that the clouds disappear, leading to plus 8 degrees centigrade or Celsius further warming. Although I expect that few humans, if any, will see that. So I'd like to thank you, Sultan Bev, for breaking this down for us and letting us see just really how bad it is, because the climate scientists aren't letting us see that. The priesthood is really not letting us see that, and they're not talking to us in these terms. This is understandable language to me, and it's the CO2 equivalent. And we've talked about that before, and you've explained it to us before. So thank you for breaking this down and showing us how bad it really is out there. And that when we see this stuff coming up, and it doesn't just have to be out of the Arctic, it's all over the place. We saw that. When we go to the globe, we have many places that have that dark brown, and it could go high. It could be higher than that, because remember, before they changed this color ledger, the original color ledger went up to 75,600. So it could be worse, and we just don't even know. They cut it off at 10,000 on this color ledger. We don't know. And we've definitely got that over here in California and throughout the United States and throughout Canada and throughout Asia and China and Russia and, all over the place. So I just wanted to share that. Thank you, Sultan Bev, for that explanation. And now I'm going to end with this blog post from Sam Carana. He posted this and then has edited it since then, posted this on Tuesday, December 17th, and I did my last show on December the 15th, where I showed his chart where it showed the, where it could increase, the temperature could increase to 18°C in very short order. So he's got a new article up now, 2 days after my last video. Says extinction in 2020? ? So just when you thought it couldn't get worse, it always can. I just want to preface it by saying that. We're going to go over this. Above image depicts how humans could go extinct as early as 2020. The image was created with NASA LOTI or LOTI 1880 to November 2019 data, 0.78 degrees Celsius adjusted to reflect ocean air temperature as opposed to sea surface temperatures, to reflect higher polar temperature anomalies as opposed to leaving out missing data, and to reflect a 1750 baseline as opposed to 1951 to 1980 baseline, with 2 trends added. Blue, a long-term trend based on January 1880 to November 19 data. Red, a short-term trend based on January 2009 to November 2019 data, to illustrate El Niño, La Niña variability and how El Niño could be the catalyst to trigger huge methane releases from the Arctic Ocean. So there you go. So let's zoom in on this. So here's 2020, which we're about to go into it. Here's the red, where it's been going along, and then here's the blue line, which is a more spread out line. So this is the air that he's measuring. Ocean air, adjusted to reflect ocean air temperature. So that's where he anticipates it without the El Niño. So by 2025, we're here with the air at above 2.5 degrees. But here we are at 2020. And here's 2021. So he anticipates somewhere between 2020 and 2021 it's going to be above 2 degrees. That's, if I'm reading that right, that's 2.1 degrees early in the year. And by 2021, if we have, this is based on, I guess, if we have the huge methane release, it could be 3 degrees higher. By the end of 2020. So, that's his new prediction. And then he goes on. How was the above image created? And first he says, let's look at the baseline, etc., etc. And he goes into this whole scientific explanation. Oh, and by the way, there's someone who left a comment saying that he thought that Sam Carana's chart was off and that we had a few more years, you know, but that Sam Carana didn't seem to back up his thing with scientific data. Well, his conclusions with scientific data. Well, you know, I don't have to defend Sam Carana. All I know is that all I see is scientific data every time I read one of these blog posts. So, there you go. You can think what you want. So, let's just pick out some key points here. As above image shows, the temperature rise of the oceans on the northern hemisphere is accelerating. This constitutes a critical tipping point, i.e., there are indications that a rise of 1 degree C will result in most of the sea ice underneath the surface to disappear. This sea ice used to consume the inflow of warm, salty water from the Atlantic Ocean and the Pacific Ocean. So while there may still be sea ice left at the surface, since low air temperatures will cause freezing of surface water, the latent heat buffer has gone. So that's this different chart. The accelerating northern hemisphere ocean is overheating. So here's got 2020 and so on and so forth. Here he's talking about the old sea ice, that there's very little old sea ice left, and so we're in big trouble. And here's where the ocean heat can get trapped. Before it was trapped underneath the thick sea ice, and here, and so it was holding down. That was a buffer to hold down the methane, but now with the thin sea ice, the methane is coming up, which is what we saw. The picnicline layer is gone, and now these columns of methane just can come right up. They can just do that. How fast could the warming strike? This is from an earlier post of his. The loss of September Arctic sea ice within years. Seafloor methane within years. Water vapor immediately. Falling away of aerosol masking effect partly within days. So within days of having these particulates fall out of the sky, you know, then you're going to have effects. More greenhouse gas releases, particularly from Arctic soils, within years, and then further feedbacks. And he added this, since he made the post. Here's an image from NOAA. This is the 469 millibar. This is actually from, it's the MEDOC-2 satellite in the afternoon on December the 20th, and we see a peak of methane of 2,737 parts per billion. Ominously, a large part of the atmosphere over the East Siberian Arctic shelf is colored solid magenta, indicating methane levels above 1950. Yeah, see? It's all the way over. And he also made up a chart, a conversion table to show the altitude equivalents in feet, meters, and millibars. So this is handy to have. So 469 is 6,041 meters, or 19,820 feet. And I was saying around 20,000 feet. So there you have it. And this one, 945 millibars, this is considered around surface level. And the less number of millibars, the higher it is in the atmosphere. And the larger number of millibars, the greater pressure, sea level pressure. So the greater the pressure, the closer it is to the ground. So he says the situation's dire and calls for comprehensive and effective action as described in the climate plan. No one's listening. Then here is links below. So I'll end it with that. So extinction by 2020. You know, anything is possible at this point. We're really in no man's land. We're off the chart and we're in no man's land right now, and anything can happen. And so this is why I say time is short and no one knows the day or the hour, but we need to be ready to leave, and we need to get our spiritual houses in order. You know, you can prepare physically as much as you want. You can prepare mentally, you can put relationships in order, but you really need to get your spiritual house in order. And get ready to meet your maker. And because no one knows when, as we can see with everything going on. So I love you guys. If you like my work and would you like to support my work, I have a PayPal link below. I also recommend, if you'd like to keep up with the methane as it is released from CAMS day by day, I do methane videos on that and other reports that I post for my members on Subscribestar, and there's a link below for that. So just in case something happens to my YouTube channel, that's going to be, Subscribestar is going to be my go-to place, and you know, I have other ways to post videos. So I also have my website. You can find me at Margo's Healing Corner too. So until next time, I hope you have a good week, as good as possible. Let's keep everyone in Australia in our prayers. And I love you guys, and I'm praying for everybody. So God bless you, and go in peace, and I'll talk to you soon.